This is a intro for the cone portion under pyramid, cone, and sphere. So anyway, I already introduced cone as part of the pyramid family. So the only difference is it is the pyramid but with a circular base. So again, there are two kinds of cone. It can be a right cone. So the top will hit the bottom right at the center in a perpendicular manner. So these two are a right cone. So this one will be in the middle. So this part will form the radius, base radius. So then there'll be this kind of oblique cone. Oblique cone is the slanted cone. So we are not going to be so concerned about oblique cone. So we will be concerned about the right circular cone. So a few things that you will need to know. This is the vertex, okay, or sometimes they call it apex. Usually call it vertex, or it's the sharp corner of the cone. So do take note. So this, when we say height, right, we talk about perpendicular height, because there's also another one called the slant height. The notation for the slant height is small letter L. And then this will be the base radius. And this will be the base radius that's going to account for the full circle. So if we see a cone as a part of the pyramid family, that means it's 1/3 base area times height. So the base area will be a circle. So the volume should very much follow by the volume of pyramid, except that we change the base area to circle because that is the base area. Okay, now for the surface area, there are two categories. We got the base, and we got the curved surface area. So this one is something that you need to take note. There are two parts to the surface area, because sometimes you may not have the base. So if the base is being covered up, you will exclude the base from the calculation of the total surface area. So this will be the base surface area, and this part will be the curvy surface area. So in what situation will you not have the base? So for example, like an ice cream cone. So the base is open up. So if I'm going to calculate the surface area of the ice cream cone, so I shouldn't have the base because it's open up already. Okay, and there are two components, the base and the surface curved surface area. The curved surface area is the one that needs you to have the L. So this is the one that most probably you might need to perform a not simultaneous. You might need to perform a Pythagoras theorem. So sometimes that is the part where you will need to perform a Pythagoras theorem with the height, with the radius, and L. So L may or may not be given to you. If it's not given to you, you got to do it by Pythagoras theorem. Okay, so that is the introduction with the cone, with the idea that is part of the pyramid family. So moving on, okay, these two examples will just illustrate the idea. So in this question, okay, for part A, if I want to calculate the volume, it's quite easy because I got the base radius, I got the perpendicular height. So that is just putting everything in. So this one is there's no trick to this. Pi r square. So usually my habit is I'll leave it in terms of pi before I punch it up. I will leave it in terms of pi before I punch it up. So if you are using the calculator pi, you will get a long chain of decimal. The question will tell you what is the value of pi to use. If the value of pi is not stated, you just use the calculator pi, or you use 3.142. If it's not stated, that is the O-level requirement. So in part B, I'm supposed to find the volume, but I do not have the perpendicular height. So my height is missing. So that is where I got to perform a Pythagoras theorem first. So by this stage, at this time, I assume your Pythagoras theorem is totally okay. So, and anyway, in this situation, right, I'm also not going to punch out my height because that is not my final answer. And if I'm going to punch out, it's going to be a chain of decimal. So I rather conserve the accuracy. So from here, I will do my volume. 1/3 base area pi r square times height. So usually I will prefer to punch out. Okay, the final part, then I will punch out. So 3SF will be your final answer. Okay, so example 6 is finding the height. So I will strongly suggest, if the diagram is not drawn for you, you draw it out. So you got a good visualization. So now it is like a bit like opposite. You are given the volume, but you do not have the height. Okay, so from the formula, keep it in terms of your pi. And this formula should be equal to 98. And just do normal algebra. And you should be able to find your height. It's just that it's not going to be a very nice answer. So if it's not going to be a very nice answer, write a few more numbers first before you conclude with a 3SF. So that is a bit like playing around with the formula for the volume part.